Formation of stars. Stars are born in nebulas. Nebulas are these huge clouds of gas and dust. And there are lots of nebulas. There are hundreds of thousands of nebulas that we can see. This one is called the Pillars of Creation. And you can see these dark clouds. These are gigantic. I think 400 light years across. Some are thousands of light years across. You can see in here little dark clumps of material. These are clouds of gas and dust. This is where the gas and dust is more compact. You can see darker places, and this is a nebula. In the background you can see another nebula. The one in the background is glowing. Here you can see this is whitish, and that's because they're brand new baby stars right in there giving off light, and it makes it glow just a bit. So here's another example of a nebula. The colors that you see are supposed to be true color, but the colors actually come from the different gases. If you remember when we looked at hydrogen, hydrogen had a bright red line. I think the red is a hydrogen gas, and helium has a bright blue line, and and this is white. It's just a conglomeration of stars. I think the red is oxygen. But they indicate the gases that are dominant. And this is called an emission nebula because it's glowing, it's giving off light. It's been heated up probably from stars that are embedded in the cloud that we can't see. Excuse me. Here's some clumps of material that we can see. This is called an emission nebula because it's giving off light. I really like this picture of a nebula. Again, you can see this huge, gigantic cloud. And it's got clumps in it embedded in that cloud. And in those clumps are where stars are going to be forming. Here's a clump right here. Here's a clump. And this is very interesting. There's probably something like over here to the left, a supernova star that exploded. That explosion sent a shock wave through the space, and here's a brand new baby star, and then that shock wave, as it passed through, blew materials away. So this material streaming away from those stars are material from that pressure wave coming through. Another example of an emission nebula. Now here we see, and you'll see a lot when you see astronomical photographs, that you'll see these spikes coming off of this star. This is overexposed because they wanted to photograph this dimmer material. And so this is overexposed, and these spikes actually come from the construction of the telescope. There's a secondary mirror in the front of the telescope, and it has to be held in place by rods that come from the side of the telescope to the secondary mirror, and the rods, when this is overexposed, make these patterns. So this pattern is indicative of the telescope, not of the stars. So here you see the nebula, and you see dark clumps inside the nebula. There's one, there's one, there's one in there, there's one there. Now, this nebula is glowing because you can see it because light from this one, the light is coming out and it's reflecting off of it. So this is a reflection nebula. It shines by reflected light. And and you'll notice that it's dark up here in front. This is a dark nebula. And it's just not hot enough to glow. And those are the three kinds of nebulas. There are dark nebulas, reflection nebulas, and emission nebulas. Here's a nice picture of a nebula, and you can see the cloud has got thick places and thin places, and it's hot enough to glow up in this region and around in this region. This nebula is a dark nebula called the Horsehead Nebula. If you remember the Orion Nebula, that pattern, the 2 stars in the corner, 3 stars in the belt, and the Horsehead Nebula is located just a little down and to the left of this left-hand star in the belt. Now, there's also, if you actually went out and looked at the observation, you'll see 3 stars in a row coming down. This is generally considered the scabbard of Orion's sword, the sheath that he would put his sword in. But you can see this middle star is visible to your eyes. You can go outside tonight and look and see this middle star. This middle star is not really a star. It's the Great Orion Nebula. And this is a stellar nursery. And all of Orion there's a real good photograph in the ultraviolet. This shows up as red in this whole region with clumps of brighter nebula material here and here. So it's a huge cloud of gas and dust. But stars form out of a nebula. The nebula begins to condense. It condenses due to gravity. Gravity pulls everything inward. So it begins to condense. If there's some kind of trigger, like the explosion of a supernova, this is a star that's exploded, then that would send out a pressure wave through the nebula, and it would condense things and create lots of star formation. But you have this great cloud of gas and dust, and if you kind of think, well, I've got this big, huge cloud of, there are going to be places in there like this one and right in here, places where there's more gas clumped together. And so clumps begin to form in the nebula. The clumps, as they contract, will begin to rotate, and they grow by accretion. Now, you need to understand what this step means. So you've got this little clump, and this clump begins to pull material into it. And as it pulls more material into it, it has more mass. Since it has more mass, it has more gravitation, and it pulls more material into it. And now it has more mass, so it has more gravity, so it pulls more material in, so it has more mass, so it has more gravity, so it pulls more material in, which gives it more mass, which gives it more gravity, which pulls more material in, which gives it more mass, which gives it more gravity, which pulls more material in, which gives it more mass, which gives it more gravity, which pulls more material in, which gives it more mass and more gravity and pulls. And these other clumps too are growing by accretion. More mass, kind of like a snowball rolling downhill, will get bigger and bigger and bigger. It accretes or pulls in more stuff. So this clumps grow by accretion. You need to know what this accretion process is. And as more material falls into the surface, that friction heats it up, and it's also contracting and getting smaller, and that heats it up and becomes a very hot clump. It can be so hot that it's glowing. It's not a star yet. This is what we would call a protostar. So a glowing, hot clump of material that's growing by accretion is a protostar. It's not a star yet. So what has to happen to make it a star? Well, we have to get a nuclear reaction going on at the core. So once it becomes a protostar, then a core begins to form. Material falls in toward the center, and it forms a dense, hotter core. That core begins spinning quite rapidly usually, as it gets smaller. And so as that core gets smaller and smaller and smaller, it spins faster and faster and faster. So that makes the material around the equator move more rapidly, while the material near the poles moves very slowly. And since that makes it easy for the material near the poles to fall into the core, but around the equator, it's going around so fast that it's hard for that material to fall in. So a disk forms around. And so we think around every star, once it forms these protostars, these hot clumps, that these clumps are going to have disks around them. And there are some good photographs in your textbook that show the material around the equators of these stars. If you have a sun-sized or smaller core, and once it's gathered in almost all the available material around it, then it's called a T-Tauri star. This is the first one was found in the constellation of Taurus. You'd have to have a telescope to see it. They're not really stars yet, even though they're called T-Tauri stars. They're not stars. Why? Because there's no nuclear reaction in the core. But T-Tauri stars will begin to emit charged particles. The disk around the star, you've got this star, this protostar, with a disk of material around the equator. Well, the charged particles are being emitted in all directions, but this disk of the gas and dust blocks it along the equator, but there's nothing to block it along the poles. And so they often form these jets of material coming out from the North Pole and the South Pole, and these T-Tauri stars. So beams of material called jets can be seeming from the poles. The core begins to collapse. It continues to get smaller. As it gets smaller, it rotates faster. It gets hotter. It gets higher pressure. And it continues to do that until a critical temperature, which is about 10 million degrees Celsius, and a critical pressure, extremely high, because we have to push these hydrogen nucleuses together. And as soon as it reaches that critical temperature and critical pressure, then we get nuclear fusion happening in the core. And it changes from a protostar to a star. And that change is almost immediate. So the steps in the formation of a star, it starts out with the nebula. The nebula condenses. There's some kind of trigger or shock wave. It could be a nearby star blowing up, called a supernova. It could just be the nearby star is hot. It's emitting the solar wind, the charged particles, and that's pushing through the cloud and forming these clumps. But these clumps form in the nebula. They begin to rotate, and they grow by the process of accretion. They get bigger and bigger and bigger and bigger and bigger and bigger and bigger. They get hot. They heat up due to friction, and these hot clumps are now called protostars. Protostars go through some stages and finally form the moment that they get a nuclear reaction sustained in their core, then they become stars. And the solar wind begins to blow away the nebula. Now, in this cloud of gas and dust, when one clumps form, other clumps form. These other clumps could be small and become planets. And so we believe that planets form along with the stars, and then eventually the solar wind would blow away this remaining gas and dust, and so the accretion process would start. Sometimes you get more than one big clump, and you get double stars, and these other clumps could, this one might just orbit around this star, this one might orbit around this star, this one might actually orbit around both of those stars. So you get very complicated solar systems. But we believe actually that every star should have solar systems. The evidence that comes up with this explanation is that there are thousands of nebulas in the galaxy. Thousands of nebulas. New stars are always formed in the nebula. Old stars are formed in thin nebulas. The Pleiades is an example. You can Google that and you find pictures of that. And old stars are never found in nebulas. There are three types of nebulas: emission, reflection, and absorption. So that's the birth of stars.